This video will walk you through some exercises in homework 3 for event studies. In the class, we use event study methodology to explore one type of announcement, which is merger and acquisition. Now here in the homework, we'll use event study to explore the market response to earnings announcement and also the market reactions to repurchase announcement. First, looking at question 1, it's actually a textbook example. You can read through the textbook if you have further confusions about the questions. So now we will use the data for an industry. So for the grocery industry, we'll consider the effect of earnings announcements on a set of different stores in the grocery industry so that we can aggregate the effects and to know the market response to a particular type of event. Now, first, we want to focus on one firm, which is Safeway. Use Safeway's earnings announcement on July 20th into 2006 as the initial example. So we'll use the earnings announcement on this day, which is 42 cents for earnings per share, and the analyst forecast is 36 cents per share. So therefore, the real earnings of Safeway beats the market's forecast or the analyst forecast by 6 cents. That's a positive surprise of 14%. Now we want to know how market reacts to it. So since some part of return is expected, another part of return is unexpected, it's driven by surprise. So we want to subtract the expected return. So we'll need to first estimate the model. So the model should be estimated during the estimation period, so some periods before the announcement. And here we chose the estimation periods 252 days before the announcement. So this will be our estimation period. So we want to, use some periods that is not affected by the announcement. Now you can change this estimation periods if you think that day -1 is also considered as an announcement period. You can choose maybe 1 week before the announcement day or 1 month before or others. So now we're going to use offset function to locate the data range. Because you don't want to manually find this estimation periods every time because the event date, so the announcement date will change. So we don't want to manually find the estimation periods for each specific announcement day. So let me just remind you how to use the offset function. So the offset function is demonstrated in the class exercise Q1. So first, Excel will need to know the reference array. So you first include all of these data here for reference array. And then the key point is to locate the starting corner, which is highlighted in this yellow. So starting corner is not some data that you're going to use for estimation. So data you're going to use for estimation is highlighted in green, in blue. So here, to allocate this, you first need to let Excel know how many rows down and how many columns to count so that you can locate this starting corner. So how many rows? So this row is B27 minus 11. So B27 is somewhere here. So count if. So select all this range, count if the data points that is before the announcement day. Announcement day is January 29th. So January 29th is here. So count how many data do you have for up to this point. So there are 19 data that you have starting from row 3 all the way to 29 to here. So you have 19 different data, 19 different rows. And then you want to subtract, you want to know the starting point. So you need to subtract the data that you use. Okay, so the data that you use is, you use 10 data here, and you also want to exclude the announcement day. So that's one data point here. So that will be, you use 19 minus 10 minus 1. So 1 is standing for this announcement day. So that means you use 19. So there are 19 here, subtracting 10 data points that you use for estimation and 1 data points that you use stands for the announcement day, that will be 11. So that's why we use 19 here minus 11. Okay, so that will be equals to 8. So row number 8 is here. Okay, so this row. And how about column? Column will be column 1, column 2. So here, that will be, so Excel will find the starting corner here. And so where will be the data consider? So the data consider will be here. So 10 rows below the starting corner. So 1, 2, 3, 4, all the way to 10 rows below the starting corner. and then one column to the right of the starting corner. So that will be here. Now we will adopt the same logic here. So the starting point will be count if. So we have so many data points here included. So from A3 all the way down to the whole area, and count if the date is greater or equals to the announcement date. So, and then we'll need to subtract the number of days that we'll use for estimation, and also -1 for excluding announcement day. So equals, so the starting point, starting row in the reference array will be row 137. And then we want to know how many columns over from the top here. So how many columns over? So we will use 2 columns over to refer to the market return. And then here, so 1, 2, 3, 4, 5, 6, 7, 8 columns over to reference for the Safeways return. And here we want to use, instead of 10 data points, we want to use 252. And the column will be 1 column to the right. So we're going to use intercept offset here, selecting data from here all the way down, comma, and now we'll go back, refer to cell B10, starting point. How about the column? The column, so this is for Y's. So Y will be the individual return. So that will be Safeways return. That's 8 column to the number 8 column. And these 2 numbers, so here and here, so identify the starting corner. So we'll already know this yellow starting corner here. And then, so we're going to use, so we'll let Excel know the data consider. So 252 rows in 1 column to the right. That's for the Y's. For the X, everything will be just the same except for the column here. So we want column number 2 for market return. So everything looks good. Okay, so that will be the alpha. And let me just check my calculation with the data reference here. I reference directly to the data points from row 140 all the way to 391. So that will be 252 days estimation period here directly. So I manually find it. So they are the same. So that means I'm located to the right reference, right data. So everything will be the same here. So offset function will be the same for calculating slope. I just need to change the function name. Okay, so good. This is the same as this one. And here, I'll also need to change it to STV, so standard error for predicted Y value. Here, we will have the model specified here, and therefore expected return will be the slope, the intercept plus slope times market return on that day. That will be here, B9, enter. So expected return is actually negative. So therefore, the difference between actual return and expected return would be the abnormal return, so here. And the statistic, T statistic will be the return divided by standard error. Okay, so that's solved question A. And you want to look at the abnormal return here, 9%, and the T statistic to interpret the results. So market reacts positively to this positive earnings surprise. And next, extend the event study to grocery industries by considering 16 different quarterly announcements. So we have 4 different firms here, and each firm has 4 different announcements. Now we'll just repeat the process. So we already know how to do it for just one firm. and one announcement. And we just need to extend our event study to different firms with different announcements. The starting point is nothing, copy in the formula here. And intercept, copy in the formula. Change the starting point here. And also we need to change the column. So the column will be, this is for Kroger. So for the market return, which is the X, this one does not change. We just need to change the column here. So let me first look at the column in the data. For Kroger, that's here. So 1, 2, 3, 4 column. 4. Then I think I can drag it. Yeah, it's changing my reference, so I want to fix the reference. Here, fix the reference. Okay, it looks good. I'll just copy everything here. Change it to slope. Drag it. Change everything here. To this. XY. STEX. EYX. Okay, so now I can copy the formula to another firm. Since it's another firm, we'll need to change the column. Okay, you cannot do the same column because we are changing the firm. Here, this is SVU. So let's see where is SVU. So SVU is here. So that's 1, 2, 3, 4, 5, 6. So 6, column number 6. And for Safeway, Safeway is in column number 8. I can drag it all the way. So here for Whole Foods, that's in Whole Foods in column number 1, 2, 3, 4, number 2, 3, 4, number 10. Change it to number 10. 8. This is number 10. Number 8. Number 10. Okay, so I can just change the color, indicating that they are using different data points. And one more thing to change in this table is this actual return and the calculation of abnormal return. I think in your Excel file here, it starts the reference array from A2. So if it starts from A2, then our starting point should move 1 point up. So go to, then the starting point should be 44. But if you change this to 3, then the starting point will be 43. So I'll just change that for each of this firm. Going down. Change it to 3. Going down. Change it to 3. Going down. Same here. So now they look good. Or question C, calculate the cumulative abnormal return over the event window from day -10 to all the way to post-announcement day 10, and make a graph for the average CAR of positive and negative earnings announcement. So I think this part will be just referring to some return, and the model that we use, or the formula that we use, is here. So we're going to use realized return subtracting expected return, and we have intercept here, slope here, and this is for calculating T. So here, these are all the models parameters that we estimate in the previous Excel spreadsheet here. And here, the starting point is also what we calculated before here in this table. And we have 4 different announcements for each firm. So there are 16 total earnings announcements here and 4 per firm. So now I think I can use, well, you can use the normal formula. So since this is cumulative, okay, so these data points are consecutive days. So what I'm going to do is to utilize the array formula. So array formula is, we're going to have one formula for all of those cells here. So there are 21 different cells here, but they will share one formula. So it will equals to, I'm going to follow this formula here. So the only thing I will ask Excel to do is to use offsets to locate the data for the realized return. And then also use offset function to locate the data for the same return, for the market return corresponding to the same days. So corresponding to day -1 before the announcement and 10 days after the announcement. So here we're going to use the intercept, slope plus intercept. Okay, so next I'll just need to locate the return. So first the reference is here, all the way down, and then the rows will utilize the starting point So we have starting point 43, and this will be the 1 day before the estimation period. So 1 day before the estimation period, and we want 10 days before the announcement day. So adding 252, so that will be 1 day before the announcement day. And we want day -1. So therefore, you can just add -10 here. So that will be the day before this day -1, day -10. So then do the column. So yeah, I'll do the column. So for Kroger, the column will be 2. And therefore, these 2 will identify the starting corner. And here will be how many data down the starting corner. So we're going to use 21 data points down and 1 column to the right. Same range here, but we'll just need to change to the market. So 2 is the market, so this will be 4. So 4 for Kroger, 6, 8 for Safeway, 10 for column. I'm speaking of column. So this 2 will be the market. So we use market return times a constant slope plus the intercept. So this will be the expected return and enter. So now let's just double check here. So here when announcement day, so day 0 is the announcement day. It has an abnormal return equals to 1.46%. So here go to the first announcement for Kroger. Its abnormal return is 1.46%, and that's correct. So we are doing this correctly. So that means we can basically drag it all the way. So I need to fix the array. Fix change this one to 6. Drag it. Here, this should be 8. Here, this should be 10. Next, we'll calculate average abnormal return for positive earnings announcement. We do the same thing for non-positive earnings announcement. So we need to first find the positive earnings announcement. So Excel has a conditional function for calculating average. So we're going to use average if. Average if first filter out the data. So filter out all the negative earning surprises. So here is earning surprises. I'm going to fix it because the surprise will be just for the earnings announcement, the specific type of earnings announcement, and that will be the same for all the following announcement days. Here, the criteria is greater than 0. And the average range is here for day -10. And you can just double click, and that will be for average abnormal return from day -10 all the way to day 10. For cumulative abnormal return, so that will be equals to here. First number will be the same. Next number will be here, the first one plus the abnormal return. And I can drag it all the way down. So for negative, it will be less or equals to 0. Enter. Okay, so that completes question C. Now what we'll need to do is to make a graph. So looking back at the question, make a graph for average cumulative abnormal return of positive and negative earnings announcement. So what I'm going to do is going to include the date, the abnormal return here, insert, this graph looks good to me. This graph also looks good to me. Scatter, let me do scatter. Or here. Or you can do here for line as well. Yeah, let me choose line. So here you can, so here I will choose line with markers. Adding one, selecting the other. This will be positive. That will complete question C. For question D, just some simple analysis on the effect of earnings announcements on stock prices. So everything is shown in this graph. So positive earnings announcement surprise has positive market reaction. Negative earnings surprise has negative market reaction on average. Now, if you look at one specific announcement, that's probably not true because it's about a lot of different firm-specific factors. But if you take the average and cancel out all of those firm-specific factors, the noise will be reduced to minimum, and you're going to see a general pattern for positive earnings surprise and negative earnings surprise. Next, move on to the question 2. We'll look at Wendy's repurchase announcement. So Wendy announced the share repurchase on November 16, 2006. And the share repurchase will be approximately 19% of its equity. So we're going to use two-factor model to estimate expected return. Now we mentioned this in class before. So the model that we use for estimating expected return is market model. Well, sometimes the model may be not good. So there can be a lot of, you can use a lot of different models to estimate expected return. So to capture some risk, common risk factors out there. Now the two-factor model is something we can change. The two-factor model is something we can use. So what the one factor that is used is the market factor. Another factor that will be used here will be the industry factor. Now there are a lot of different factors out there. So people will know like size is also a common factor. Value, book to market is also a factor. Momentum, idiosyncratic volatility, those can also be the factors. So investment, profitability, those can also be factors. Here, just to illustrate by this example, we're going to use industry factor. So the industry factor is given by this S&P Restaurant Index. So we're going to use S&P Restaurant Return to proxy for specific industry factor. And the first question we'll ask is, what are the expected return due to the exposure to market factor on this two specific day? Now we have the return data here. We're going to go to the model. So the model here shows us the return and market return, industry return. The announcement date will be November 16. Let me double check. Yeah, November 16. We'll need to calculate expected return and take the difference, accumulated, finally take the t-stats. So how to estimate two-factor model? We cannot use intercept and slope function anymore because that's for univariate regression. Now, what we can do is to utilize the regression function in Excel. So how many days are there in the estimation window? We're going to count days before the announcement, 257. Okay, so we'll include the day before. So with this, in this case, our specification of announcement window will be changed. So the announcement window will be 1 day before the announcement all the way to 1, 2, 3, 4, 4 days after the announcement. And the estimation window will be 2 days before all the way, including the previous days. So 252 previous days here, okay, for this estimation window. To start the estimation of two-factor model, you're going to use another function in Excel to run the regression. Instead of using the Excel function, you can go to data. So data analysis here. If you don't see data analysis, go to files, option, add in. Make sure that you check the box for analysis toolpack. Click OK, go to data, analysis, choose regression, click OK. And the Y's here will be when this return. X is S&P 500, including the industry index. So the output, I want to output it to this spreadsheet. And you can choose whether you want to include residual. We'll choose yes. And also you want whether you want to plot standardized residual, no. Okay, click OK. Okay, so the regression model will be Y. So the company's return, so Wendy's return of Wendy equals to intercept plus beta 1 or slope 1, let's say beta 1 times RN, market return, plus beta 2 times our industry return. So in this case, it will be equals to here equals intercept hits here plus beta 1 times market return plus beta 2 times market return, enter. Now I want to fix the model parameter. Abnormal return will be the residual. Here, that will be the difference between real return minus abnormal expected return. For cumulative abnormal return equals here t-test will be here, the abnormal return divided by the standard error here. Okay, and the expected return due to the market factor on this 17th of November will be equals to the coefficient here, the beta times market return on the 17th here times enter. For the expected return due to industry factor, that will be industry beta times industry return, enter. If you add these two together and plus the intercept, that will be the expected return on this day, mainly driven by the industry exposure. And then on 20th, same. So we're going to use the market beta times market return on 20 equals to industry beta times industry return in 20 of November. So on the 21st of November, the expected return is 0.02%. And most of them is due to the intercept here. And looking at the exposure, the sensitivity of Wendy is returned to the market return. So Wendy is positively related to the market and also the industry. However, they are not fully exposed to the market factor and also industry factor. If they are 100% exposed to these two or even leverage more sensitive to them, then this coefficient will be probably greater than 1. So this will answer question A. So for question A, expected return due to the market factor on these 2 days, that will be 0.05% and minus 0.03%. And then due to the industry factor, that will be negative 74% and negative 0.08%. And make a histogram for expected return, cumulative abnormal return, and abnormal return for when this during the event window. Finally, for creating the histogram for expected return, abnormal return, and cumulative abnormal return, so you're going to select these 3 guys, insert cluster column, select data, give a name for them, and also give the value for the x-axis. Okay, and also a chart title. And you can answer the question here. Did the repurchase affect when this returned? So first look at abnormal return here on the announcement day, which is 16. So that's fine. But after that, after 16, the market reacts pretty negatively. So on the 16th, the immediate reaction is negative. And the day after, reaction will be also negative. Cumulative effect will be negative.